We are here with Paul Mitchell. He is the president of Indy Autonomous Challenge. What are the main objectives of this competition?
So Indy Autonomous Challenge has really three main goals. The first is to advance technology and accelerate the pace of technology commercialization. So we do this by working with industry partners who provide us the hardware and some of the software which goes on to these autonomous race cars, and we're testing them to see how can autonomous technology function at extremely high speeds. We have a second goal, and that is to attract the top talent from around the world to work on this challenge of autonomous mobility. And the third is to entertain. It's to win hearts and minds, to get people exposed to autonomous technology in a way that's fun, in a way that's exciting, and maybe for them to say, okay, if a car can go 170 miles per hour or 300 kilometers per hour by itself, maybe I can trust this type of technology in the future. Yeah.
So very interesting. It's a kind of a laboratory. Are OEMs nowadays taking any advantage of what's happening here?
So we work primarily with the tier one component suppliers. So people who are producing LiDAR, radar, other hardware. So companies like Continental, Luminar, Bridgestone, Cisco, AWS, these are our primary sponsors and partners. We have started talking to some of the automakers, but keep in mind, usually the automaker is integrating those technologies from other suppliers.
Okay, in each race, the winner is who goes fast, or are there other criteria?
So they have to race each other. So we first set the grid. We determine which team is in which position based on top speed, so based on time trials like you would see in Formula One or other racing. And then we run head-to-head racing competition rounds. So 2 cars at a time, always 2 cars, never more than 2 right now. And those teams pass each other at increasingly higher speeds, and the speed keeps increasing until one team either cannot pass or there's a wreck. So it's sort of in America we call it like a game of chicken. Who can go faster and make more passes at higher speeds? Yeah, and then the winner of that round goes to face the winner of a previous round. So it looks like a tournament.
So it's undoubtedly a challenge because it's really a competition inside the track between 2 cars.
That's right.
Okay. Here we are in a fantastic oval speedway. Do you consider to have these races going on traditional circuits too?
So we started with ovals because our primary objective was high speed autonomous mobility, and of course on ovals you can achieve very, very high speeds consistently. It's also safer in terms of the technology and the infrastructure is a little easier to build out and maintain in an oval track. However, now that we've been running for the past couple of years at oval tracks throughout the United States, we are exploring transitioning to road courses, and we'll have more to say about this this week at CES, actually.
At CES. Okay. How do traditional IndyCars fans see these kinds of competition?
I think it's mixed, like anything.
Mixed feelings.
Yeah, mixed feelings. So first of all, I think the race teams, the technology companies, people involved in the technology of racing are very interested because they see this as an opportunity to advance safety technology, which can help human-driven race cars go faster, safer, right? Maybe eventually we can have an Indy car that can go 275 miles per hour, something like this, right? You can't do that without additional safety systems, and that's the kind of technology we're testing on these vehicles. Other people look at it and say, "Oh, without a driver, what's the fun? It's not exciting." My answer to them is that we do have a driver. Our driver is a robot. It's AI driver, and each driver has a different personality. They have a different driving style. It's a replication of the team which coded and produced this AI driver. So if you see our team from Polytechnic of Milan, they have a very different driving style than, let's say, the team from Technical University of Munich.
Wow, that's interesting. on reality, the teams compete in terms of being the driver.
Yeah.
No, they are really the driver of the car. They don't touch in the mechanical things of the car.
That's right. So the cars are all identical. Indy Autonomous Challenge builds up and maintains and services, repairs the cars when they're wrecked, and we have plenty of wrecks. And we get the hardware, the technology which goes into the car from our sponsors. We couldn't do this without lots of top corporate sponsors who want to test their technology in this way. So then the teams, they're the driver, they're the race strategy, and they will code that software to be able to control these cars. So it's really the teams are essentially, as you said, they're the drivers.
So the competitors are essentially universities from US and Europe. How can other universities compete in this challenge?
So we have universities competing from the US, from Europe, from Asia. We have a team from the Korean Institute for Science and Technology, and then one of our European teams is also partnered with an institute, Technology Innovation Institute in UAE, in Abu Dhabi specifically. Okay. So we're global. We have different parts of the world that are represented. We welcome more universities getting involved. One of the ways that teams can get involved is through simulation racing. So it takes a while to get your driver trained to be able to drive these $1 million cars. It's very expensive to maintain a team, to travel to these venues, and of course when they wreck the cars, the teams are responsible to cover the cost of fixing the cars. So the best way for a team to get involved, at least initially, is by participating in race simulation rounds. And this year we're going to be talking about our plans to bring back some of these kinds of sim racing, which will make it easier for teams to participate and compete. And if they do well in the sim racing, then they can progress on to running these cars at tracks around the world.
Okay, Paul, thank you very much. Congratulations for this incredible laboratory that you have here. It will be undoubtedly very important for the future of autonomous cars. Thank you very much.
Thank you very much. Really, the credit, though, should go to the universities who are in this competition and to the sponsors, but we're proud to be able to host these kinds of events.
Okay, thank you, Paul.
Thank you very much.